Hello and welcome to NGen Math 8 by eMathInstruction. My name is Kirk Weiler and today we're going to be doing Unit 1, Lesson 1, the first lesson in this course. This first lesson is on operations with signed numbers. You're going to be seeing a lot of positive and negative numbers throughout Math 8. You'll see them in applied settings, but you'll also just see them in kind of standard, hey, let's solve an equation and it has a negative as an answer. All right, so it's very important that right at the beginning we review things like how you just add, subtract, multiply, and divide numbers that are both positive and negative. So let's get right into that review in our first lesson of NGen Math 8. All right, here we go. The first thing we're going to do is we're going to talk about addition of signed numbers because this is the most basic of all things, right? Let's take a look at exercise number 1. It is important to be able to add simple and relatively small signed numbers without a calculator by thinking about how positive and negative numbers cancel each other in addition. Find each of the following sums. All right, so again, let's just talk about it. You know, there was this famous movie called Stand and Deliver where this math teacher says, you know, if you scoop sand out of a hole at the beach and you put it to the side, right, the sand is a positive. The hole is a negative, right? And those two cancel each other out when they're added together. So when I see something like -8 plus 14, right, that literally means I have 8 negatives, or 8 negative ones, 14 positive ones, and there's going to be some cancellation when they add together. In fact, 8 positives will cancel with 8 negatives, and they'll leave me with a positive 6. I never need to put the plus in front of the 6, right? If there's not a negative sign sitting there, then it's implied that the number is positive. You could put a positive there, but you don't have to, right? So I'd like you to think about letter B and letter C, and then let's revisit those two sums. All right, well, in letter B, we've got a -20 and we've got a positive 15. And of course, the way I want you to think about this is, oh, there's more negative than positive. So when we add them together, our final result will be negative. And what will our final result be? Well, I can kind of think about it as if I took away 15 positives from 20 negatives, I'd be left with 5 negatives left. 15 positives will cancel 15 negatives, and I'll be left with a -5. Now, the last exercise, -6 plus -10, well, literally, I have 6 negative ones and 10 negative ones, and when I add them together, I get 16 negative ones, right? That's just what I have. So when I have a negative added to a negative, I just get more negative, right? Nothing cancels there whatsoever, just as nothing would cancel if I added two positive numbers together, right? So this basic notion of when you add positives and negatives together, they cancel out to be 0. For every -1 you add to a positive one, those cancel and give you a whole lot of nothing, right? So you want to be able to think about that as you add positives and negatives. All right, let's move on and take a little look at subtraction and how we can convert that to addition. All right, converting subtraction to addition. Let's take a look at exercise number 2. Convert each of the following subtraction problems into an equivalent addition problem and then evaluate the sum. Well, just for a moment, let me explain sort of the idea behind this. Subtraction is not nearly as nice as addition. And the reason for that is subtraction doesn't have the associative and commutative properties that addition does. So it's good to be able to take something like 10 minus 3 and rephrase it in terms of addition of a negative. So 10 minus 3 is obviously 7, right? And we would get exactly the same calculation if we rewrote this as 10 plus -3. All right? Every subtraction problem can be changed into an addition problem by simply adding the opposite, positive negative wise, of the number that we're trying to subtract, right? So let's talk about these two actually together. So 9 minus 20, right? Positive 9 minus positive 20 would give us exactly the same thing as if we had 9 plus -20. right? And that will be negative 11. Okay, and that should make some sense. You know, if I was at 9 degrees Fahrenheit and the temperature dropped by 20 degrees, I would end up at negative 11 degrees Fahrenheit. The final one is really quite important because I'm subtracting a negative. And whenever you subtract a negative, you can turn that into adding a positive, right? So this would all become 6 plus positive 2 or positive 8. All right, it's very, very important to be able to change subtraction into addition. And we're going to be doing that a lot in this first unit of Math 8, so you're going to get a lot of practice on it. All right, let's keep going with signed numbers. All right, using the properties of addition. So this is why we wanted to be able to change subtraction into addition, because addition has two fantastic properties, one of them being commutative. Commutative means that if I add two numbers together, like 3 plus 4, I get exactly the same thing as if I get 4 plus 3. I can switch the order of addition between two numbers. Associative property says that if I'm adding 3 or more numbers together, I can pick the two that I want to add together first. Now that's extremely helpful when we have a lengthy calculation like this that involves signed numbers, it involves addition, it involves subtraction. It's nice to then be able to use the properties of addition to be able to think about these sums and differences. So let's take a look at exercise number 3. For each of the following expressions, do the following. 1, rewrite using only sums, only addition. Number 2, group the positive together and the negatives together. And 3, find the sum of the positives, the sum of the negatives. And finally, 4, find the overall sum. All right, so here's my point. We could work this calculation from left to right, all the way over. But what's kind of nice is to be able to say, all right, let's group all the positives. Let's group all the negatives together using the commutative and associative properties of addition. Then let's find out how much positive we have in total, how much negative we have in total, and then we can think about cancellation. All right, but we can only use the properties of addition if we change all the subtraction into addition. So let's work through letter A together, then we'll have you work on letter B on your own. Let's do it. All right, I'm going to bring the screen up a little bit here. So I've got 7 minus 10 plus 2 minus 5 plus negative 3 plus 11. The only things I'm going to change about this is I'm going to write this as 7 plus negative 10 plus 2 plus negative 5 plus negative 3 plus 11, right? Now it's all addition. It's all addition. So what I'm going to now do is I'm going to take all of these positive numbers and I'm going to sum them. This is the associative property. Then I'm going to take all those negative numbers like negative 10, negative 5, and negative 3, and I'm going to sum those. And this should be easy. 7 plus 2 is 9, plus 11 is 20. Negative 10 plus negative 5 is negative 15, plus negative 3 is negative 18. And now 20 plus negative 18 is easy. That's positive 2. Right? Now, again, you could do that problem by doing the following. 7 minus 10 is negative 3. Negative 3 plus 2 is negative 1. Negative 1 minus 5 is negative 6. Negative 6 plus negative 3 is negative 9. And negative 9 plus 11 is positive 2. You can totally do that. There's nothing wrong with that. But it's also nice to be able to rearrange this kind of thing so that we can see all the positive quantities, all of the negative quantities, and then how those finally cancel out to leave us with this, in this case, positive 2. Pause the video now and try letter B. Again, rewrite as addition, right? Group all positives and negatives together, sum the positives, sum the negatives, and then see how they all cancel out. Take a little bit of time now to do that. All right, let's get back to it. Let me draw a little line down here to separate everything out. Let me first rewrite. Nothing I have to do with the negative 8. Nothing I have to do with the 9, but then I'm going to rewrite that subtraction by 2 as addition of negative 2. Then I'm going to rewrite that subtraction of negative 5 as an addition by positive 5. Then that's an addition of positive 3, and then I'm going to rewrite that as an addition of negative 10. Again, I'm going to take my positives, 9, 5, and 3. I'm going to group those. And then I'm going to take my negatives, -8, -2, and -10. I'm going to group those. I'm now going to add that. 9 and 5 is 14, plus 3 is 17. -8 and -2 is -10, plus another -10 is -20. And 17 plus -20 will leave us with a net -3. All right, there we go. Getting out of the way so you can see it. Check your calculations. Again, it's fair to say we could do this on our calculator, right? But it's also fair to say that we shouldn't. All right, these kind of smaller calculations with integers, we're not even talking about fractions or decimals or anything like that, that have negatives and positives in them, are important just so that you understand how these types of numbers work, right? Without doing this, if you're doing it all on the calculator, you're just getting an answer and you have no idea why it's there. Let's keep moving along and take a look now at some multiplication and division involving signed numbers. Haha, multiplying and dividing signed numbers. Now, this works a little bit differently than adding and subtracting, right? But the nice thing is that there's a consistent pattern about it. And it basically goes like this. Anytime you either multiply or divide two numbers that have the same sign, the result is positive. And anytime you multiply or divide two numbers that have different signs, i.e. one's a positive and one's a negative, the result will be negative. So let's take a look at exercise number 4. For each of the following, fill in the blank with the word positive or negative, and then state the result of the calculation. So let's go through this together, because I think that this is really quite an important thing. You're going to be seeing multiplication and division of positive and negative numbers throughout your mathematics career, no matter how far you go in it. So let's go through each one of these together in turn. Letter A. A positive times a negative equals a negative, right? Anytime you have two numbers that have different signs and you multiply or divide them, your answer will be negative. So positive 8 times negative 5 will be negative 40. All right, and again, let's kind of back out just for a moment, because it's not all about just whether it's positive or negative. It's also about how big the number is. And the idea is, if I see something like 8 times negative 5, what I want to think of is, well, 8 times 5 is 40, right? But because one of them's positive and one of them's negative, the grand result is a negative 40. So you're still going to find the sort of the answer to the product or the quotient the way that you normally would with normal multiplication and division. The question only is the final result positive or negative? So let's go back to the board. Letter B, a negative times a positive, therefore, would be a negative. Again, anytime we have two numbers that are multiplying each other that have different signs, we're going to end up having a negative. So here our example is negative 1/2 times 20. Well, 1/2 times 20 would be 10, so negative 1/2 times 20 would be negative 10. All right, so letter C, a negative times a negative. Well, now since we have a negative times a negative, anytime the two numbers in a product or a quotient have the same sign, then their product or quotient will be positive. So a negative times a negative is a positive. Negative 4 times negative 7, well, 4 times 7 is 28, so negative 4 times negative 7 is also 28. A positive divided by a negative, again, we have that mix in signs, will be a negative. And therefore, 48 divided by negative 4 would have to be negative. 48 divided by 4 is 12. So 48 divided by negative 4 is negative 12. A negative divided by a positive, well, that's going to also be a negative because they're mixed signs. Negative 72 divided by 9 is going to be a negative. 72 divided by 9 is 8, so it's going to be negative 8. And finally, a negative divided by negative is a positive. Anytime we mix, when we have the same sign, we get a positive when we multiply or divide. Negative 36 divided by negative 9 is going to be positive 4. Again, it's simple enough. If I take two numbers that have the same sign and I multiply or divide them, not add or subtract, but multiply or divide them, then I'm going to get a positive. Anytime they have opposite signs, when I multiply or divide them, they're going to turn out to be negative. So now let's use all of this to further evaluate numerical expressions. Now, in order to do that, we've got to have order of operations. So keep in mind, in terms of multiplying, dividing, adding, and subtracting, multiplication and division come first, addition and subtraction come second, and we work from left to right. All right? So let's take a look at exercise number 5. Find the result of each of the following expressions. All right, let's do it. Here we go. So, letter A. We take a look here. We've got negative 3 times 7 plus negative 5 times negative 2. We've got to do those products first, so let's do that together. Negative 3 times positive 7 will be a negative 21, right? Because one of them's negative and one of them's positive. Negative 5 times negative 2 will be a positive 10, because they're both negative. Then negative 21 plus positive 10 will end up having a net negative 11. Right? So we have to do this combination. Oh, okay, I know how the products work. I get their answers. Then I sum together and I get that negative 11. Let's take a look at letter B as well together, because it's a little bit strange, right? And before we go to the screen, right, let's take a look at why it's strange. We have 8 minus 2 times negative 7, and we have to be very careful. It's very tempting to say, oh, well, 8 minus 2 is 6, and then times negative 7. But no, we actually have to do this 2 times negative 7 first. So let's do that together. Right, 2 times negative 7 is negative 14. And we have 8 minus negative 14. Sometimes we'll put a parentheses there because it just looks a little bit nicer and it's easier to separate the difference between subtraction and negatives. Now, keep in mind, anytime we subtract a negative, or anytime we subtract at all, we can change that into adding a number of the opposite side. So 8 minus negative 14 is the same as 8 plus positive 14, and that ends up being 22. All right, finally, let's look at this last expression. Right, in this last expression, we have negative 5 to the second power plus 3 times negative 5, and then minus 8. Okay, we have to do the exponents first, then the multiplication, and then finally all the addition and subtraction. So let's do that together. Now, what do we have here, right? Negative 5 squared is literally just negative 5 times negative 5. Now, I could evaluate that right away, but I just wanted to write it out for a moment so that we could think about it. Negative 5 times negative 5 is positive 25. 3 times negative 5 is negative 15. And then I have that minus 8. Now, I could combine that negative 15 and that negative 8 into a negative 23, right? By thinking about that minus 8 as plus negative 8. Then 25 minus 23 leaves me with 2. Of course, I could also just say, well, I've got 25 plus negative 15, therefore I have positive 10, and then 10 minus 8 is positive 2. There's a lot of different ways to actually go about doing these calculations in terms of thinking about subtraction versus adding negatives and what have you. All right, let's keep going. Last slide. So the final thing we want to look at is fractions and signed numbers. Now, we should never forget two things. One, a fraction is a number, right? It's not a nice number, right? We would rather deal with numbers like 5 and 10 and 22 rather than negative 2/3 or 7/5 or whatever, but it's still a number. It represents a quantity. But the other important thing we should remember about fractions is that they also represent division, and therefore they play by the same rules that division does in terms of positives and negatives. So let's look at exercise number 6. Simplify each fraction. If the result is an integer, state it without a denominator. All right. So the first thing I want to look at is this, negative 3 divided by 6. Now, one thing I know right away is that the result of this division must be negative because the numerator is negative and the denominator is positive. But then I really just want to think about the fraction 3/6. 3/6, of course, reduces down to 1/2. So negative 3 over positive 6, if you will, is simply the fraction negative 1/2. negative 1/2. Now likewise, letter B, I have negative 24 divided by negative 3. So I know, right, I know that the answer here is positive. So a negative divided by a negative is a positive. And now I can think about what is 24 divided by 3? Well, that's simple. That's a nice integer, right? That's 8. So my final answer here is positive 8, right? Here I've got a negative in the denominator. I've got a positive 20 over negative 16. So I know the result of this must be negative, must be negative. Now this time it doesn't turn into an integer, but I can reduce the fraction 20/16 by dividing both the numerator and the denominator by 4, and my fraction is negative 5/4, negative 5/4. And finally, my last fraction, negative 9 over negative 27, because I have a negative divided by a negative, the resulting fraction must be positive, right? And I can then reduce it by dividing both the numerator and the denominator by 9, giving me a fraction of positive 1/3. All right? So it's important to be able to take fractions that might have negatives in the numerator or denominator, or possibly both, and simplify them into a single fraction, right, that is either positive or negative, right? So I've got like a positive 1/3 versus a negative 1/2, and also be able to simplify that fraction. All right, let's wrap up this lesson. So we saw a lot of review today, right? Nothing today should have been new. This was all from Math 7 and Math 6. The ideas of how to add and subtract signed numbers, how to multiply and divide them, and even do some more complicated calculations in terms of order of operations. And finally, how to simplify fractions that have negatives in the numerator, denominator, or possibly both. All right, we're going to be doing a lot of work that involves negative and positive integers and fractions as we move on. So make sure that you do the homework and really, really try to understand it. For now, I'd like to thank you for joining me for the first NGen Math 8 lesson by eMathInstruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.